Hi, and welcome to this presentation. My name is Christopher Undheim, and I work as a DBA at dbWatch. The topic I will talk about today is called Beyond Instance Tuning, Optimizing SQL Server Farms. This talk is structured so I will first compare farming to database management and how we are getting into a situation that is in many ways solved by farmers already. Then we will see what we can learn from their solutions and how that applies to SQL Server farming and their optimizing and tuning. And finally, we will dive into the more technical details on how this can be done in practice. But first, we need to step back in time. Some years ago, a farmer could live quite happily with 4 cows. They would have names like Rose, Flower, Daisy, and Bella, and the farmer knew each and every cow, talked to them every day, milked them into a bucket, and cleaned up after them. But no farmer can make a living like this anymore. And some years ago, a DBA only worked with a few database servers, where the DBA would know them all and their function and could log in and check everything every day. And I remember how this used to be. I could set up and configure the hardware for my database servers, and I could spend days or even weeks tuning and adjusting for any minimal improvement. Those were the days, and they're not coming back. This is 42 cows, and this is not uncommon for one farmer to work with today. However, I think this is around the time where they don't feel they have a strong personal relationship with each and every one of them. This is also about the time where we start seeing names like 578-47563812-0032 on the cows. This being a cow from Norway, 578, farm identifier 47563812, and cow number 32. And at this point, you will still know a few of the cows, maybe the ones that have a special pattern on their hide. But you can't pet them. You can't pet each and every one anymore. You can't milk them by hand, because it takes 30 minutes to milk a cow by hand. It is done at least twice a day, and 42 cows means 42 man-hours per day. And it can't be done at any time. You have to do it in the morning and the evening, so maybe you need 10 people involved just to milk. And of course you need machines to help you with milking and the other processes of managing cows. Without machines, the cows would be neglected and suffer, and the farmer would suffer too. And we see that the skill set of the farmer has also changed. Being an expert in milking by hand and measuring the food output each cow, based on experience and knowing the personality of each animal, so you can tell if something is wrong, it's not so important anymore. Operating the computer that controls the milking machine, and adjusting feeding robotics and integrating cow metrics with automated veterinary systems are. This is 42 database instances. And this is around the average of what we see one DBA work with today. And same as for the cows. For me, this is the time when I don't feel I have a strong personal relationship with each and every one of them. This is also about the time when we start using names like db-ws8-s-32 on our servers to encode the information about them, or metadata, in their server names. We try to build structure and control this way. And this could be a database server with Windows SQL Server 2008, located in Stavanger, server number 32. At this point, you would still know a few of the instances, maybe the ones that cause problems. And only by the power of scripts and Excel, you will know the IP address, the version, session code from last week, disk usage from some time ago, and memory usage from God knows when. You'll be sort of in control, some of the time, but not always, and not when it needs to be. A lot of the DBAs will find that when the number of databases increase and the size they manage is higher than what you can check in a day, your control starts slipping away and reactive DBA works, and putting out the fires takes precedence over the proactive DBA work that would have kept everything running all of the time. And if you manage this without the right tools to do so, your databases will suffer, your users will suffer, and you will suffer. But also, the skill set of the DBA has to change from being the expert in tuning large SQL statements or manually tweaking memory settings or creating your own scripts, maybe. That skill set is going away. You need automation, consistent deployment, standardization, farm management. Other things will be valued. This is what 170 instances look like. And a lot of places, the DBA would not know that they had 170 instances. If you ask them, they would say, we have many database instances. And you'll get a rough number. But a DBA can no longer have the time to log in and manage each individually. They need tools to provide this overview and to give them control of their database farm. And when a database farm gets to this size, your DBA will struggle to rely on their own customized script, because as the size grows, the number of platforms and versions will increase, and it makes it difficult to build and maintain their own tools. And maybe the creating and maintaining of these scripts turns into a full-time job. You can't, as a DBA at this point, spend any length of time tuning the individual instances. There will be enough running around trying to fix preventable crashes to allow for any sort of proactivity, let alone any tuning. And this is a database farm with 1,200 database instances. You know they will all be named something nearly identical. And you all know that when you have a farm like this, you need software just to count them. And know the skills we mentioned earlier: automation, consistency, standardization, farm management. It's impossible to manage this well without. And how can we optimize this sort of environment? What things do we focus on when we optimize one instance? We could make sure that the hardware has enough CPUs and memory and disks for the application, and we can set up and configure the instance to utilize the hardware correctly, tweaking memory areas and parameters, and we tune the SQL statements to improve performance, and much more. And for what? We optimizing one instance is optimizing for hardware utilization. And when you look at optimizing a farm, the focus changes to areas such as standardizations and consistency, where you compare and monitor differences in your environment. You adjust automatically settings that need to be identical, comparing versions and patch levels so you know when something is out of sync, detecting and adjusting instances that are not consistent. You have automation where all the maintenance routines are deployed, working identically on all database instances, and you have adjustments to tuning that are deployed across the farm. You have fixes that are possible to predict. They can be implemented automatically. And you have improved workflows that help the DBA prioritize the important tasks, and you have alerting to the right part of the organization about the problem. And this will improve the time to use to correct issues. But what we optimize for? Optimizing a farm is optimizing for DBA time. optimizing DBA time will lead to benefits in performance and resource usage as well. Just as a milking machine optimizes primarily the time a farmer uses to milk cows. But you get benefits in increased milk production per cow because milking is consistent. It's not too early, it's not too late. And also, it's been monitored and measured. Optimizing DBA time leads to benefits of overall performance improvements and resource usage because you get compounding effects on the tuning that is done because it is done across the entire farm. The database farm anyways is running database instances that they are running on your farm is anyways running on a few physical servers, and they're eating from the same resources. Performance tuning on the entire farm reduces overall load and helps you better target the resources you have where it's needed, and it's also saving costs. And the lesson we have back in the days when we did individual instance tuning, tuning that database is the law of diminishing returns. Focusing the efforts on tuning the easy wins on a lot of instances will be a better use of your time than squeezing the last drop of performance out of just one of your instances. And the tuning efforts that can fix problems across the entire farm will add up. If you get a 10% improvement on all your instances, that really stacks up. Sometimes in life, you will have the opportunity to start all over. We start with the right skill set on how to run a farm, and we can set up the right foundations and structures before we start getting all those cows or database instances. But most of the time this is not the case. We start looking into this when we are in the process of being overwhelmed by the cows or the database instances we have. We know we need to take action to move from having cows to running a farm. We need to move from having databases and managing a database farm. But what would you start with as a farmer? Well, if you have cows that don't produce milk, they're better suited as steak. Yeah, you need to send them to the slaughterhouse. It's quite obvious because if they don't make milk, you can't keep feeding them, can you? You're wasting your food. It should be that obvious when we manage database farms as well. Still, we see that this job is not often done in the world of database farms. But the job is quite similar. You all have databases that are not in use anymore. But while new databases are very easy to get, old databases seem so hard to get rid of. But why is this so hard? Of course, it might be easier to see if a cow doesn't produce any milk, but that's only because it's being monitored. You know, you measure the amount of milk a cow produces, and you need to monitor if your databases are not being used as well. How can you keep your farm running optimally if you don't know what information is important and in use, and what information is redundant? What is your process of making sure that all your data is relevant? If you have 100 database instances with 100 databases on each, that is 10,000 databases. Which ones doesn't produce the milk anymore? This is a list of instances of databases that are not in use on instances. So you have nobody that logs in, no changes are made, nobody reads the data, and for quite some time. That's a waste. You're wasting your food, which is in this case the CPU, the memory, the disk, the backup space, and most importantly, your time on looking after databases with data nobody uses. And once you know this, it's so easy just to put them offline. Wait to see if someone is screaming, and of course make sure you have at least one good backup, and then just remove them. and it can even be done automated. And you can also check which databases are in use, so that you know which one are important. Now, if we move back to farms, now that you are left with only cows that produce milk, it is time to look at managing the time that you spend better. Well, you wouldn't think about milking them by hand, so of course you bring on the robotics. And there is robotics in database farms too. The super DBA that logs in to rebuild indexes or repeat fixes must be used better. Automated maintenance for index rebuild, reorganization, fragmentation. You automate the backups, you automate the routines to adjust known settings and performance issues automatically from one central location, standardized, monitored. And once it's deployed, you need to be able to quickly see if your automation is running perfectly. This is an example of index rebuilding across a farm. And as you see, one of the instances have an index that is too large for automatic rebuilds, as you would define in your standards. And this could be an index that is so large that you want to do this job in a scheduled maintenance period. Or you can have a dbcc check db. It has to be done. And if there is issues in the maintenance, you need to know right away. Maybe its maintenance job cannot complete within the allocated time frame, or you have other errors. And what else would a farmer do? Did you know that in modern farming all cows have a medical journal? And that the milk from each cow is analyzed for any medical issues, and antibiotics is adjusted in their individual food for each cow based on their findings? And if you find something that can't be auto-adjusted, or you detect medical issues that require the veterinary to check it out, the farmer gets notified so that they can get in their veterinary. We must do the same. Standardized monitoring, farm-wide deployment, and any health issues that can't be corrected right away must alert the right person. Before anyone else notices, the DBA can then enter and save the day. But maybe also adjust the automation to catch and correct reoccurring problems. If you need to fix something twice, the third time it should be automated, because repeating the same task over and over again, it's not optimizing DBA time. It is also introducing the chance of it not being fixed in time, and that problems affect the end users. And once you know how all the instances are behaving, you can relax with the instances that have no problem and focus your efforts on the instances that are reporting problems. So, if you have healthy cows that are producing milk, you might want to analyze the milk production and improve it. But what type and amount of food is best to achieve this for your farm? A farmer would look at his computer screen for the output metrics for milk per cow, and the resource settings for the feeding report, and then adjust. Maybe just for one cow and try it out, or maybe for the entire herd. A DBA should do the same. You should look at the performance dashboard, find if databases are misbehaving, and adjust their food, and check if they are getting better results. What you want to do here is finding what minimal tuning can be done to benefit the farm. Maybe one or two database instances need special attention, as they could be impacting others too. You need both a total overview of the resources you're using, and the ability to check the activity and memory allocation to make sure that the instances are using the right amount of memory. Adjusting memory on an instance can also be auto-tuned so that they get allocated the memory they are using, and when there is less load, it is auto-tuned to a lower setting. Or you could look if there is instances where the databases are fighting for resources. That could result in unexpected performance changes to the database. It is important to stay on top of how the farm is working, to stay in control and to work on proactive DBA work. Have to avoid getting problems in the future. There is a reason why farmers focus on one breed of cow. The cow breeds are different. They need different food. They produce different milk, or they are better suited for steak. Multiple breeds makes it difficult to streamline the farm. Like the farmer focuses on one breed, a DBA must try to standardize versions and patch levels and platforms as much as possible. Get overview of your versions and patch levels and employ consolidation as an ongoing procedure. It's not a project. And this makes your farm always right-sized. When you have an overview of what is running on what versions, you can then use this to plan for better structure. Because overview is essential for good decision making. And you can of course combine this with reporting that will both let the management know that you're doing a good job, but with reports for yourself that looks through the resource usage so you can know which instances can be combined. Moving from database instance management to SQL Server farm management requires us to think new in terms of how we look and communicate with the databases. We require a different language to define what we want to look at and how it should be presented. Farm management, farm optimization requires much more than we looked at today. But how do we start to take control of SQL Server farms? We need to make something new to control the farms. We have created a query language to make this possible. A new way to bring together all the data we can find across different database versions, database platforms, and indeed any data source. Before we can optimize the SQL Server farm, we need control. To understand how this works, we need to go back to how we communicate with databases today. If I want to know anything about the database instances I have, I need to query the databases. And for this use case, I have 4 database instances: Manda, Silos, Cecid, and Tatooine. They're all SQL Server database instances, and 4 is not that many database instances to manage. What I want to know today is how many user sessions are connected to each database instance. And to do that, I need to run a SQL query. And I have a query I want to run that counts up the number of user sessions they have. It is highlighted here in red. And that is my favorite SQL Server counting sessions, but not the background sessions and task manager query I have. So I run this query on each database instance, and then the result of the queries has to be copied from the SQL query output and pasted into an Excel spreadsheet for my analysis. And you will end up with something like this. I think this is something most DBAs do regularly, and it's quite straightforward and easy to do. When you don't have to do it all the time, and you just have 4 data instances to manage. But it's quite boring and repetitive. And sometimes you might have another database platform you need to report on as well, or you have different versions where your SQL query isn't identical. But here I have a reluctant Oracle instance I haven't been able to remove yet, called Tanab. And the query is not compatible across different versions or different database platforms. So, and this could always also be the case if you have a SQL Server on premise and you have some databases in Azure. I think it's reality most places. And often when I work as a DBA in the past, I got the responsibility not only for the database platforms I knew pretty well, such as SQL Server or Oracle, but also some platforms I hardly knew at the time, such as MySQL or Sybase, that were left over from some old piece of software that I hoped I never needed to fix. But I still needed to report on them and to make sure that they didn't stop working. And what you end up with is multiple queries that you have to run. One for some instances and others for the rest. And you also need to keep track on what queries should be run on which instance. In this case, I only have SQL Server and Oracle, but it's still two different queries that do the exact same thing. They count users but not background sessions from a database instance. And for each metric I want to look at, there is a new query. Two different queries for instance name, two different queries for session count that we have looked at already. I have two different queries for disk usage and two different queries for memory usage. So only when we want to look at these simple metrics, the instance name, the session count, the disk usage, and the memory usage, and we have two platforms, we end up with 8 queries we need to maintain and understand and use to query the data we need. And we need to pick the right one to run on that instance. So we need to know the instances we manage quite well already. And that can be a problem in itself, of course. But I think that most DBAs, they have a long list of these SQL statements that they use to gather different bits of information from the database instances they manage. And when you get bored of the manual job of running the query and copying and pasting the results, you start looking for ways to avoid this manual labor. So maybe you make them into a view or join them together, so at least you don't have to run all the queries independently, and you'll end up with something like this. So 4 metrics for each database platform joined together, and maybe it's more like stitched together. But this has one drawback. As a DBA, you will likely end up with many of these nice to have but very complicated queries. And I have spent many hours looking for the comma that went missing, or the single quote that turned into a backtick, or the parenthesis that went missing. And you might also turn them into a script, but that's very inflexible, because when every time someone asks you for a new metrics, you have to dive into that old code with lots of these complex queries to sort out. So when we find a good query, wouldn't it be nice if we could just create an alias for each of the queries? So when we need the result of that query, we just ask for that alias, and if we need result of the other query, we just ask for that alias, instead of having to merge and join the difficult queries together. Say we give the name of the instance query the alias name, and the query behind the session count the alias total session count, and the query about disk usage the alias disk usage, and the memory usage query the alias memory usage. So this way, at least when we have found the right query, it stays right, and if we need to correct it, it's just a simple query that can be easily understood. So imagine just running this simple query on each database instance, just querying the alias and having that alias automatically resolve the different queries for the different platforms and versions. Wouldn't that be a good idea? And there is a natural way of structuring these aliases. Some concepts like memory usage and total session count will have a single value that is associated with that instance. But other concepts like age and job is a list where each element have a list or a set with properties. This result is a structure similar to a directory structure used to organize files on a disk, or the tree-like structure of an XML document. FTL is a language created for transformation for this type of information into queries. Each of these nodes is a result of a SQL query. So in the case of total session count, there is the same SQL query I used manually on the 4 instances, but when it's defined as a node in the FTL structure, instead of running it manually on each database instance, it's queryable as the value of the property in the FTL tree structure. We define this in XML as a property which has a key and a value. The key here is total session count, and to limit queries to run on only the instance database types that this query work on, it has a compatibility tag. It is in itself it is a query on the different properties. So in this case, database type. This allows a given property key to have multiple definitions, so that each database type might get their own SQL query. So now the problem we had earlier, where we needed to remember to run the right queries for the right database platforms and versions, is taken care of. This is very important part of how this can function on multiple database platforms and versions. Compatibility allows for multiple queries to gather the same type of data from multiple sources. Any property can be a compatibility tag as well. So you could make another property definition later based on total session count, so that property only would run on database instances with more than 100 sessions connected, for example. Then we have the value definition, and this will give the property key, total session count, its value. It says it's used the SQL engine to run, and it's a SQL statement, just like the one we run in SQL worksheet. And the last parameter here, valid for, it's a cache hint. It is how long this value is valid for before we should start a new SQL query to get fresh data. Here it's set to 1 minute, since the information about how many user sessions are connected to the database instance, that changes quite rapidly. But for other queries that are heavy and doesn't change that often, maybe a valid for of 24 hours is the correct setting. This parameter is important to offload the database instances when you have data that needs to be queried quite frequently. FTL queries is somewhat similar to a directory path. It's a bit like directories and files. If we want to get a value, we type the path and the value is returned to us. We start with a simple query. We ask for the name of the instance. This is a similar query in FTL as when we did individual SQL statements and put them into Excel. We just write instance/name, and we get the value for the property name for each instance. In the background, the SQL statement for the name property is run on each instance, and the answer is cached. So if we query this again, you will get the cache results. Then we can add column formatting, so that the column is that used to be called name is instead formatted as a database instance. This is often what we do in SQL statements as well when we want to give the column headers a better name. Now we have a new concept. It's called an anchor. This is a reference pointer that allows us to join two properties together. The instance node is anchored to the I variable, and this allows us to start from the same node item each time we query a subnode or a child node in the tree. We will use this in the next step when we add a column to the query. We use $i to refer to the same instance element again when we query the value for total session count, formatted as session count. Now we have joined two properties together. in such a way that both the value of the database instance name and the value of the session code refers to the same database instance. If we didn't use this to connect the two properties, it will just be two columns that are not connected, so you can have the instance name of one instance and the session code value from another instance. Since we use an anchor, we open the possibility to query multiple values at once, starting from the same node item. For instance, if we also want to look at disk usage displayed alongside with the database instance name and the session code. And this allows us to put together information from many different queries into the same result set, and also data that doesn't naturally join together in other ways. Now we've added disk usage alongside this query, and we get a view that contains multiple key metrics for that database instance. And now we have something that could solve our initial problem of querying and merging data from multiple database instances using different aliases. It is in fact a bit like how a data warehouse works, where multiple queries extract data, transform them, and connect them together again, and allows you to query on top of that data. But with FTL and the caching engine, it's done on the fly in real time, and it's very easy to implement an add-on. And every time we have a new alias we want to create, it's just a few lines of code in a file, and new items can be queried across all your database instances. But even though we mostly talk about SQL queries, this can also be used to take input from other sources as well. We see in the definition of our query in the property definition that the type of engine is set to SQL. There is a reason for that. It is not to limit the functionality to SQL queries only. Maybe you have information located elsewhere that needs to be added into the view. This could be information that is located on the host machine itself, or maybe on a web server. Or it could be a mix of data that needs to be put together. And sometimes the information you get from a query is not formatted correctly for the value you want to give the property. And then you have to add a processing engine. So this flexible query structure enables multiple engine definitions, where one engine can feed data into another. From query engines such as SQL, SSH, other FTL queries, or you can feed data into processing engines like regexp or JavaScript that can feed into newer processing engine or query engines. We will look into a few examples on how this can be done. So there we have an example that uses SSH to query the host of the database instance for its hostname. The only major change from the SQL property is that it now is compatible with the OS type of Linux, and that the engine name is called SSH. The query is just a command that is going to be executed in the shell on the database instance server. And here is a more advanced example that uses an SSH shell command where the output then is passed to another engine. In this case, it's a regexp engine as input, and since this is like a waterfall type model where the engine line on top feeds data to the engine line underneath, and queries are run in order in the order they have in the definition. And then the structure of a node and its child node are defined from the results of this regexp. Multiple engines can be combined to create advanced properties that merge information together in a way like in a data warehouse system where the ETL extract, transform, and load, but it's completed on the fly and on demand. And you can also add programming logic into this, where a JavaScript routine processes the data that is gathered by other queries, like one SQL query that returns a text, a URL text from a table called URL info in the database dbWatch. and this is given an outscope, which is a reference pointer that predefines a variable in JavaScript. And we get a string from a FTL query that is the property name, property called metadata underscore URL string, that is given the outscope string to find. Both of them is used in the JavaScript routine that downloads the contents from a web page, checks for a string, and then the result is processed in the if-else logic to set a property value accordingly. And there is many ways this can benefit from multiple sourcing and post-processing. And one important benefit is the possibility to integrate with organizational data, because most companies have a lot of data about the systems they manage. And this data can be in many different locations and sources, and when you export this data again for reporting or maybe into Excel, you can enrich it with information such as customer name, database location, SLA requirements, or links to documentation or whatever. So there is other areas of farm management as well, but I won't go into everything today. Because managing a database farm is much more than the optimizing that I've shown today, and there is more parts to optimizing as well. But there is a lot to look into if you want to reproduce and improve the automation that is done when farmers manage cows into the world of databases. And yeah, I know that my clip art may be not the best, but just like running cattle farms has moved from the old ways of manual labor into something more like a factory producing milk and meat with industrial methods and machines that help the farmer, so will the world of database administration move into the role of the data manager. The ever-increasing amount of data and sources of data will force this to happen, if it hasn't happened already. Here the DBA will need to refocus their skills to gather a skill set change it from manual tweaking and individual tailoring into standardization, consistency, automation, and control. This is my slide I usually have when I do this live for questions, but if you have any questions, I can be reached at per at dbWatch.com. So thank you for your time. Have a good day.